one, the second line you add another one. I'm just simplifying it for you for better understanding. Plus 0.02, that's the second line. Then the third line you add plus 0.02, 0.16, that's the third line. And we got here 0.17. So here the third line, you look at it, you have 1, 2, 3. So it should fall within this range where they meet at 90 degrees. You put your coordinate there, dot on the line. So you proceed 2.0 in the voltmeter. 2.0, you have it at 0.30. So that one is already given here, 0.30. You have it here. So voltmeter 4.0, at 4.0 you have it as 0.50. At 4.0 we look at it, 4.0. On the ammeter reading current we have 0.50. So we plot that. Yes, let us look at the third coordinate for the 4.0 is here, take note. Then 0.5, 0.50 is here. So where they meet, this will give us here. You're supposed to use a pencil, but I'm using a pen so that it can be clear. So the next one, 5.1. 5.1. Now in the vertical axis we see each line 0.1. So we have 5 here. Here is 5. Take note of it. The next line will be 5.1. So let us look at where we have 0.6 on the horizontal axis, 0.6 and 5.1. We have this 0.6 is here and 5.1 is here to the small second line. Then from there, vertical axis, we have 7.2. Where do we have 7.2? 7 is here. So 7.2 will be in this second line. Let us look at the horizontal. What do we have there? 0.95. So we have 0.9. 0.9 is here. Each line is 0.02 in the horizontal. So when you add 0.02, you will have to 0.9, 0.92, 0.94, and we have what? 0.95. So that will be just after this second line here. So we have it here. The other one is 7.2. So it's supposed to be within this range. Take your time. 7.2 and 7.2. So you have it for second here, just in the middle. Then the next one, on the voltmeter we have 9.0. We look at where we have 9.0. So let us look at under current. We have 1.0. We look at where we have 1.08. So we look at it, 1.08. So here we have 1.9, we have it here, then we have 1.8. 1.8 will be around here. Each line is 0.02. So here, then we have one here, 1.02, 1.04, 1.06, 1.08. That will be here. And then we look at where we have 9. So it is at this line here where we have 9.0. So we have seen it. Let's do 0.0246 and here. So from there, 10.1, we look at it. 10.1 will be here, this one, but let us look at the corresponding ammeter reading. We got it as 1.20. Where do we have 1.20? Is here. It's already here, 1.20. That is in this thick line, and here we have it at 10 point. We have it at 10.1. So this 10.1. Now you have to use a straight line passing through the origin. It may not be necessarily almost, it is passing almost through the origin. It may not be necessary passing through all the points. Yes. So we have it. But as I touch most of the points are touch. So we have gotten our graph almost, it passed through the origin. This is our line. You have seen it. We have plotted all the coordinates. Now let us proceed. From there, determine the slope. Now slope, the formula is change in y over change in x. But here, the slope, in fact, we got it from the convenient points in a right angle triangle. So here, let me use here convenience, a place where you can easily get the figures. So I can get a right angle triangle here to make it much easier. This change in y, I'll use here my slope. I have to write it here now. The formula slope, I'll use change change in voltmeter reading over change in ammeter reading. So now my slope, I can get it change in voltmeter reading, that's here. Got it. It's in a form of positive, and you use it at this side. So we look at here, we have where it meet the line. We have it here as each line is 0.1. So here we have 8, 8.1, 8.2, 8.1, 8.2. 8.3. Let me just say 8.3. You have to take the higher number. Take note. 8.3 minus, you subtract it, the down one, 4.0. 4.0. Let's see, we got this one. Take this figure here, from here, and from here. That's the vertical y-axis, but here we are using the voltmeter reading from the question. So from there we come to the horizontal, the x-axis. So here we take it here, the higher number is at 1.0 divided 1.00, so this is 1.00 minus, we look at here, it is at 0.50 minus 0.50 minus 0.50. Now let us see what are we going to have. 8.3 minus 4.0. So this thing, we have 4.3 divided by 1.0 is the same as 1 minus 0.5. We got it as 0.5. Now we divide and see. 4.3 divided by 0.5, we got it as 8.6. So 8.6 is our slope. Yes, we got our slope. Now from there, the last question reads, from the graph state the relationship between I and V. Let us look at our graph. So here we have voltmeter reading and current. You look at the line. So here, as the voltage increase, the current also increase. You have seen it. So here from Ohm's law, the relationship is that the relationship between I and V is voltage is directly proportional to the current. So voltage is directly proportional to the current. And when you look at this Ohm's law, that is V equals to IR, Ohm's law, current directly proportional to the voltage and inversely proportional to the resistance. So this is Ohm's law, but this is the relationship they're asking us, and this is what Ohm's law, in case they ask you who state the law. So we have seen it. We have successfully gotten all our answers. The first one, identified apparatus X. Since it can be adjusted, we have to know that it's a variable resistor. In most cases, variable resistor, you have them like this. So, but here we have to know that it's a variable resistor. They can be adjusted. That's the answer. Take note. The numbers, we got them. The ammeter reading 0.30. Sometimes it can vary, even the slope, but it has to be within this range. We got it as 8.6. We plotted the graph successfully. You have seen it. So it's not difficult, just take note. And the relationship as voltage increase, current also increase. You have seen it. So they are directly proportional to each other. Thank you so much.